Good morning, friends of Lambda Island. It is Sunday, it's early, it's still dark out. It's the 6th of December, which means that kids all over Belgium, where I'm from, are waking up now and are nervously going down the stairs to see what Sinterklaas has brought. Um, so Sinterklaas, Saint Nicholas, a little different than Santa Claus, because we have the American Santa Claus as well for Christmas, but 6th of December we have Sinterklaas, and he brings candy and toys, and yeah, let's see what kind of presents Sinterklaas has brought for us today at Advent of Code. I had a look at today's questions. At least part one seems absolutely trivial. So I'm going to start with that, see how quickly we can do part two, and then I'm going to revisit some of yesterday's solutions, kind of see what other people came up with. A couple people send in their solutions so that I can graciously, quote unquote, nitpick them. Going to be nice about it, of course, but we can all learn from each other. Yeah, let's go. So basically, okay, what's the plan today? I'm not gonna spell out the whole story, but basically we get an input like this. So there are groups separated with a blank line containing entries. So these are supposed to represent groups of people and the answers that these people left on multiple choice questions. So in this case, there are three people, and the first one answered yes to question A, and the second one answered yes to question B, and the third one answered yes to question C. Whereas here there's one person and they answered yes to all three questions. But really what they're asking is how many unique questions were answered yes in each group. So for instance, in this case, the fourth group contains four people combined. They answer yes to only one question A, so that the number for group 4 is 1. So really what they're asking is, how many unique letters are in each group. So I'm just gonna bang those into sets, run a count on it, add it together, and I think that should be what we need. Which also means that I'm just gonna straight up do this on the real puzzle input. What did I name my text files? And now you see my code. I probably should figure out this auto switching again because I keep forgetting to actually show you guys or you folks my code. So here is our puzzle input. Just gonna slurp that, do the same thing that we did before. I'm not gonna, so I learned about split lines during this Advent of Code, but in this case I'm gonna do what I did before and just split it on a double new line. So now we get that, right? Let's put that result buffer on the right. Yeah, so groups. And yeah, like I said, I think what it really comes down to is like map groups, and then we want to stick them into a set, and I'm just going to do it in a single pass. Just going to comb this together. Stick it in a set, count that set, and then add all of that together. 7611. So either I massively misunderstood something, or this is no, that's not the right answer. Okay, so I did misunderstand something. Oh wait, there's still new lines in there. There are still new lines in there, yes. How about now? Yeah, we have to wait 1 minute. So let me do this. No, let's just. This has to be right. 7110. You have 4 seconds left to wait. 7110, 7110. There you go. See, I knew it was not that hard. Okay, part 2. Okay, now it gets slightly more interesting. So you don't need to identify the question to which anyone answered yes. You need to identify the question to which everyone answered yes. Yeah, everyone answered yes to 3 questions. In the second group, there is no question to which I don't want to. Okay, sure. So yeah, marginally less trivial. In this case, I guess I do have a good use for split lines. Right, here we have these lines. Yeah, I'm just gonna continue with my setsa. Because, so if I... And this intersection, yeah, it takes a number of sets, so we can just apply that. So if we say, you know, map this to sets, and then take the intersection of all of those sets, and then count that again. And yeah, just gonna keep it simple, kind of same thing as before. Reduce plus map over this one. Actually, this is a great use case for a transduce. Hey, how often do you spontaneously get to use a transduce? The first is the X form, the cross form, or the transducer. So we just use a single arity map. I'm going to add it all together, and we do that for all the groups. 3, 6, 2, 8. 3, 6, 2, 8. All right. Yeah, I remember from last year, like, getting so frustrated with some of the exercises, and I feel this year it's all been like pretty trivial so far. But maybe I'm just sort of only remembering my trauma from those last couple of days before I would just throw in the towel. They always start off relatively easy. I think around day 10 usually, I guess it starts getting a bit more challenging. But it seems last year there were some exercises that were just, yeah, really hard for pretty much everyone. And I wonder if they toned it down a little bit this year. Because, yeah, I mean, that's, you know, we can clean this up or whatever, but that's fine. I think that's fine for day 6. This is my final answer. But I also wanted to revisit day 5 a little bit. So a couple people have sent in their solutions, and I'm gonna look at those on the stream in a second. Now, I thought I was already pretty smart, or I don't know. I felt good about myself realizing that the input yesterday were really just binary numbers in disguise, right? What I didn't realize is that here, these entries. So let's look at puzzle 5 input, right? So yeah, B and F stand for 0 and 1, and R and L stand for 0 and 1. And in the description, you know, they talk about rows and columns, and you know, if you implement it, if you basically model what they describe, then you end up making it way more complex than it needs to be, because this whole thing is just a single binary number. Like if we take the binary number of these 3 bits, that's like, you know, values 0 to 7. and then add that to the value of these bits multiplied by 8, I mean, that's just the same thing as taking the binary number of the whole thing. So that means that our seed ID is actually, if I'm not mistaken, bits to num. Right? I mean, I think we can literally just get rid of this function and call bits to num here. Yeah, let's make sure we have everything. Yeah, same thing. So that's a little silly. What I also realized, I was like, you know, doing my best to do this all proper with these bit shift operations. Shifting one bit to the right is just multiplying by 2. And then once you've multiplied by 2, the lower bit is always 0. So then ORing this with either 0 or 1 just means adding the bit. And then, yeah, I would maybe go as far as to just turn this into an inline function. So yeah, with all of that, you know, this is not real code, then yesterday's solutions is pretty tight and minimal as well. Now, as I mentioned, you know, instead of actually processing these bits, you could just do integer parseIn with a second argument, which gives you the base integer parseInt or long parse long. What several people also did was using read string. So just putting that 2R in front of there and then letting the Clojure reader turn this into a number. So this is, of course, you know, it's Lisp. We have a reader and a printer and we can use them. Some people use Eden read string. So that's from Clojure Eden, which is, of course, a little more proper, especially, you know, if this is like outside input. But I mean, for advent of code, you know, read string also works, and you don't even need to require anything. So that's something I saw. Yeah, as predicted, though, like not everyone noticed that these things were just binary numbers. So quite a few people did this kind of, you know, loop, low 0, high 127, and then yeah, just kind of process the characters one by one. What I also saw and what I didn't quite expect was people starting from a range and then using take and take last to sort of chomp off parts of the range until in the end you end up with just a single row. So yeah, here that's really kind of modeling quite literally the way that the solution is described, right? But like you see also with today's exercise that sometimes you just need to take a step back and it's like, okay, you know, like instead of modeling exactly what they're describing in the description, what are they really asking? Now take last I don't see a lot, and I actually had forgotten that that is a thing. And I was kind of surprised even that take last is there, because Clojure is so adamant on not supporting features that are potentially slow, and there's no way you can do this without just doing a linear search. How does this even work? So it loops over, or it starts with as, and then it just calls next s and next lead. Oh, okay, yeah, this is kind of the rabbit in the hare kind of algorithm where it's iterating over the sequence and a sequence with a number of elements dropped until that last sequence runs out of elements, and then you know that the first sequence has the amount of elements left that you need. I was kind of expecting it to use count and then to rely on drop, because then at least for counted collections, you only would have a single pass over a single collection. Does also rightfully point out that for vectors there is subvec, which is a lot more efficient because it really just sort of gives you a view over a slice of the vector. So yeah, drop last, take last. Don't see those a lot, but sometimes I'm sure they're useful. So a couple people sent in their solutions. I did a call on the video yesterday asking people to post links to the solutions in the GitHub comments. So Pranav sent this one in. He said, hey guys, I'm a beginner. Go easy on me, of course, you know, like we're just here to learn from each other. And I mean, this is fine code. If he's really a beginner, I mean, I think this is already pretty good. I'm just gonna nitpick a couple small things that I've seen here. Yeah, so first of all, you know, you don't need those multiple requires. That can just be a single require. Here I had to look twice what's actually happening. I think calling this seek is very confusing. I mean, you're shadowing the seek function, but also the thing that is being passed in here, like, yes, okay, it's a seekable collection, it's a 2-element collection, but really it's a tuple, right? Like, so for me, things that I refer to in my code as sequences are things that I'm doing sequential operations over, map, filter, reduce, you know, things that I'm treating as a seek. And that might have, you know, an arbitrary number of elements, which I don't know. In this case, I'm really using it, or it's really being used as a positional thing, right? As a 2-element tuple. So instead of seek, yeah, I would call this anything else, tuple pair. But probably I would really just destructure that immediately here. Here also a little thing, just kind of a little idiom. If I want to check that something is one of several things, instead of just writing like all these ors, use a set. They're great for that. Boom. And if that's a little too much magic, then you can stick a contains on there. But yeah, this is nice and concise. And yeah, here this floor int kind of threw me off, but I didn't solve it this way, so I was kind of expecting that it would always be a multiple of 2, but I think it's kind of one off, and that's why you need to floor it. I'm not sure. But we'll see another person who did a similar solution, but they used quote. And quote is nice because it's in this case because it's integer division. So if you do quote, 7-2, then you don't get 3.5, you get 3, right? And if you do 8-2, you get 4. So it is basically what they're doing here, like dividing and then taking the floor of that. That is equivalent to using quote. Quotient is what it stands for. Pretty standard loop recur to then go over this. I mean, this, I suppose, could also have been a reduce or something. Oh yeah, because here, okay, so this is, I was kind of looking at what's the terminating condition here. And the terminating condition is that C is smaller than count string. So really it's just looping over the string, right? Yeah, because then here it's saying end string. Okay, so it's basically emulating like a Java or a JavaScript or a C style for loop, right? Where you like loop over an index, and then using that index, you get stuff in the string. That's a little superfluous. I probably would have just gone over the string directly, because in this case, the C is really just used for the index, right? You don't really need it for anything else. So then I probably would have done something like this, say like character and the rest of the characters are string, and then as long as you have a character, process that, and then here you just pass the rest of the characters. So this is kind of a typical pattern for if you do want to process a sequence like this using loop recur, then you would probably do something like this. But a reduce, I think, would also have worked well in this case. Can we try that? So I mean, because really, so we're starting from this init, we're looping over the string, and then it's just dig. The only thing is that the arguments are swapped. Let's see, does that still work? Am I not telling you all nonsense? Vector cannot be cast to number in get seed in multiply. So I think somewhere I am swapping my pair versus. I think I got the order of things mixed up somewhere. Yeah, I'm not gonna stare at this too long. I'm sure I'm almost there. So yeah, but all in all, pretty decent solution. Good job, Pranav. And then for the second part, yeah, so this I thought was interesting, like that also for this last bit, people definitely took some different approaches. What they're doing here is basically just saying, okay, what's the lowest and the highest number in this range? And so, we know that exactly one number in that range is going to be missing. So add the numbers that I have together, add the complete range together, and then subtract one from the other, and the result is going to be the missing number. So it's kind of clever. Let's see. Bob Latige also sent in their solution. So yeah, similar approach. Here you do see the quote. Here you do see that they use a reduce. Tiny nitpick, I would probably put this as here. If it's kind of there, it's harder to parse. If you're gonna start putting stuff on new lines, then don't have that one parameter dangling there. Here you don't need a merge, so this is something that, classical kind of Clojure beginner thing. I mean, it seems totally reasonable, right? But merge is actually comparatively slow, and if you're just gonna add a single thing, then just use assoc. And even if you're adding multiple things, like you can actually assoc multiple things in a single pass. And I think it's more clear in this case what you're doing. It's definitely faster. So yeah, don't use merge if you don't need it. Yeah, and so here missing number, they actually took kind of a similar approach, but instead of adding the numbers together and taking the difference of those two, they took the difference of the sets. But same idea. A couple of people on the stream by now. Hi Alexander, hi Dosbol, hi Vincent. Great to see some folks around. Here I don't like this in the sense that, like, add requires for the stuff you're using. I mean, it works and it's advance of code, so I mean, of course it's fine. And it works in Clojure for stuff that Clojure core itself already loads. but it's not a great habit, because you might start using namespaces that are sort of loaded by another namespace that you're loading, and then something changes, load order changes, and it gets here without that namespace being loaded yet. It's also just more declarative what you're doing, and it's important for Clojure script. So you can't do this in Clojure script even if the namespace is already used somewhere else earlier. Clojure script will not be happy. You need to tell it which namespaces you're using. And that's of course because it needs to do static analysis, and so the same goes up for static analysis tools in general, that it's they're gonna like it better. You'll have fewer surprises if you just require the namespaces you're using. Same here, I guess, for the split lines. And then tiniest of nitpick. These are all things, I'm saying nitpicks. If this was a pull request, I would be like this, this can go in like this, but here is some remarks if you do still want to improve this stuff. So if you're gonna load stuff from resources, then use IO resource. IO resource looks for stuff on the class path, which means that you're kind of future proof in the sense that if you ever want to bundle this as a jar, then your files can be in a jar. And if someone wants to provide their own version of a file, they can put it somewhere in a directory, add that directory at a higher precedence in the class path. So it's much more flexible. It's a bit more descriptive. Yeah, that's Bob Laptige's solution. Good job, Bob. I'm hoping I'm not butchering anyone's name. I'm really sorry. Please do leave a comment how I should pronounce your name. And then we have Zheng Xin Hui's solution. Here I am relatively certain about the name because I'm pretty sure that is Mandarin Pinyin, but I don't know what the tones are. Although I guess for the last name, that's probably a pretty common Zheng. So here's more a code golfed version, right? Clojure is not the greatest language for code golfing, but you can get pretty concise in a one-liner. Yeah, not gonna. A couple interesting things here. I think one thing. So where I did the sum when thing to sort of loop over a collection and terminate early. They use reduce and reduced, which is of course also a great option. I don't use reduced a lot, but maybe that's actually one of the better options for this. It's always like I've always felt that Clojure should have kind of a find function where you just give it a predicate and a collection. And it's basically the combination of first and filter. The official explanation is that they don't do that because it can't be done efficiently, and so if you need that, it probably means that you need to look at using a different data structure or something like that. But sometimes you do need that, like it's not that out of the ordinary. Pretty much every other language does have it. If we have take last, drop last, we could have had a find, but okay, that ship has sailed and don't think they're gonna add it now. So yeah, we have several options. There's first filter, there's sum when, and then there's reduce reduced. Now Vincent is saying reduce versus sum depends if nil is a valid output. That is true, of course. Yeah, so with sum you can't return nil. If nil is your termination point, then you're gonna have to do something like reduce reduced, or false for that matter. If you're looking for the first thing that is false and you want to return false in that case, then you can't do that with sum when, but then you also can't do that with first filter. So yeah, reduce reduced is, I guess, the more general. But yeah, generally Xinhui, pretty cool, very concise, like it. All right, that's it for today. It was a very short exercise, but we got to look at some code from yesterday. Hope that was fun, and I'll see y'all tomorrow.